is condensing and using the properties of logs. We'll start with expanding and then we'll move into condensing. Again, all of my notes are in Google Classroom completed, so hopefully that helps. Hopefully you're able to simplify these really easily. Whenever you multiply, you add exponents. It would just become x to the 7th. Speed review. Whenever you divide, guess what? You subtract, and we talked about why this makes sense. X cubed. Here, it'd be x to the 3rd 6 times, which would result in 18 x's, so you could just simply multiply. We're going to use all of these and apply them to logs. It makes sense. If exponents and logs are one and the same, then the properties of exponents would sort of apply to logs. Very, 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 very useful in upper level mathematics, specifically calculus. It'll make your life so much easier in calculus. So, if it is a product, what we're going to do is we're just going to rewrite it with a plus. And that's it. So, this is just very simple to start. Log base 4 of x. We're going to put a plus in between. Log base 4 of y. Double check. No exponents. Say if it was x squared, the 2 would just fall to the front, which is what it shows here. Powers just fall to the front. And that's why it became in the front. Nothing else. That one's essentially done. Gonna try the examples just below since I'm zoomed into this spot. For number 6, we see it's a product. So I'm going to put log base 7 of 49 plus log base 7. Notice I'm keeping the log and the base the same of x to the 3rd. I have one more step, so this one is not done yet. First, if you can simplify numerically, doesn't always happen, but if you're able to, you want to do that. For example, 7, can you take 7 to the power to get 49? Sure, 2. Doesn't always happen. Like for number 7, you can't get 7, so you just leave it go. But here you can, so we'll simplify it to 2. Plus, second thing, exponents are going to fall to the front. So 3 log base 7x. That is the answer. And we're going to go the opposite way as well, and we'll do that in a minute. For something like number 8, whenever you see division, it is subtracting. So I'm going to first put the log base 7y. That's in the numerator, so I'm going to keep that positive. Anything in the denominator, you'll see that there's this product here, but I'm going to put a minus in front. So minus log base 7 of 3. Another example here, numerically, 7, we can't really have a nice exponent, like here we need 7 squared with 49. But 7 to what power is going to give you 3? We don't really have anything for that, so we'll just let it go. Minus, because the x is also in the denominator, so that is why I'm keeping it a minus. Log, and I'm leaving room there purposely, base 7 of x. Since the exponent of 2 is with x, it's going to fly right to the front. So I'm sort of skipping that extra step of rewriting, because I ran out of room. Gonna try number 9, because number 9 is just a little bit different. I'll run through 5 to 9 actually. For number 5, there's a product in the numerator, so that will have the plus, and then subtracting in the denominator. So hopefully you can try that, and again, check your notes with mine. Same thing with number 7, product in the numerator, so that will be added together, drop the 3 in front of the log base 2x, and then you'll have subtract log base 2y. Just to review, a square root is equal to, like say if we have the square root of x to the 1 over 2 power. That is super important because we know here in this case it's going to be x to the 1/2 and y to the 7/2. How did you get 7? Well, because there's a 7 right here. So we're going to put their products, they're being multiply together, so log base 3 of x. But instead of putting the 1/2 as a power, I have to drop it to the front. Plus, because it's product, there's no division there. Log base 3 of y. Drop that exponent to the front, so 7/2. And that's literally how you would go through those. So I'm going to try a couple examples of condensing, just the opposite of what we did. Just did, and then probably in this one. Oh, I found my thing. So here, you want to double check the log bases should be the same, which they are. So what we would end up doing, since it's adding, we're going to make it a product. So log base 4. So we're doing the opposite of what we just did. And we're going to multiply. 10 times 5. You could leave it that way. It sort of bothers